Hello everybody, this is Srimati ASHWINI, Assistant Professor of Mathematics. We have already learned the definitions of monotonic sequences. Now let's solve few problems on monotonic sequences. The first problem says, check whether the sequence an is equal to minus 1 by 2n plus 1 is monotonically increasing or decreasing. So the main concept which you have to remember is, we have to find out an plus 1 minus an. If it is greater than 0, we say it is monotonically increasing. If it is less than 0, we say it is monotonically decreasing. So let's see what happens to this particular problem. So an is given as minus 1 divided by 2n plus 1. I need to find out an plus 1. And how do we do that? We would be replacing n by n plus 1. So we get minus 1 by 2 into n plus 1 plus 1. When I multiply 2 individually, I get it as minus 1 divided by 2n plus 2 plus 1, which is minus 1 by 2n plus 3. Now, let's find the value of an plus 1 minus an, which is equal to minus 1 by 2n plus 3 minus of minus 1 by 2n plus 1, that becomes plus. So we have minus 1 by 2n plus 3 plus 1 divided by 2n plus 1. So our LCM would be 2n plus 3 into 2n plus 1. On cross multiplying and simplifying, we get minus 2n minus 1 plus 2n plus 3 divided by, let's not simplify the denominator, keep it as it is. So you get 2n plus 3 into 2n plus 1. 2n gets and minus 2n gets cancelled. So we get 2 divided by 2n plus 3 into 2n plus 1. This is greater than 0. Therefore, an plus 1 minus an is greater than 0 for all n belongs to n, or an plus 1 is greater than an. Hence, the sequence is monotonically increasing. Okay, the next problem is, show that the sequence is monotonically increasing where an is equal to 1 plus 1 by 3 plus 1 by 3 square and so on plus 1 by 3 raised to n. Now this is an. To find an plus 1, what we have to do is, we write the same terms as it is plus add a next term, which becomes 1 divided by 3 raised to n plus 1. Now we have to find out what is an plus 1 minus an. That's equal to the entire an plus 1 term minus the an term. When you look into the particular problem of this step, all the terms gets cancelled except for 1 by 3 raised to n plus 1, and you again know that this is greater than 0. Therefore, an plus 1 minus an is greater than 0 for all n belongs to natural number, or an plus 1 is greater than an for all n belongs to n. Hence, this sequence is monotonically increasing. There's a next problem which asks us to show that the sequence 1 by n is monotonically decreasing. That is, we have to get a negative value when I find an plus 1 minus an. So let's take the given sequence an as 1 by n. So an plus 1 becomes 1 divided by n plus 1. Now an plus 1 minus an is equal to 1 by n plus 1 minus 1 by n. So taking LCM and cross multiplying, we get n minus of n plus 1 divided by n into n plus 1. n minus n gets cancelled. So we get minus 1 divided by n into n plus 1. This is less than 0. So we have proved an plus 1 is less than an for all n belongs to n. Hence, the sequence an is monotonically decreasing. Now let me see your next problem. This says, prove that the sequence n by n plus 1, where n belongs to natural number, is monotonic. So since it is given as just monotonic, it can either be monotonically increasing or monotonically decreasing. So we write an as n divided by n plus 1 and find out what is an plus 1? That is equal to n plus 1 by n plus 2. Now, an plus 1 minus an would be n plus 1 by n plus 2 minus n by n plus 1. So, LCM is n plus 2 into n plus 1. After cross multiplying, we would be getting it as n plus 1 whole square minus n into n plus 2 divided by n plus 2 into n plus 1. So, we use a plus b whole square formula and expand, and after simplifying, I would be getting it as 1 divided by n plus 2 into n plus 1. So, this is greater than 0 for all n belongs to n. This means that an plus 1 is greater than an for all n belongs to n. Therefore, the sequence an is monotonically increasing and hence it is monotonic. Now let's see the next problem. It says, prove that the sequence an is equal to 1 by 2n plus 5 is monotonic. Again, here we can get monotonically increasing or monotonically decreasing. So this is our an. Let's find out an plus 1. I would be replacing n by n plus 1. So it becomes 1 divided by 2 into n plus 1 plus 5. This becomes 1 divided by 2n plus 7. Now, an plus 1 minus an becomes 1 divided by 2n plus 7 minus 1 divided by 2n plus 5. So, on taking LCM and simplifying, we get it as 2n plus 5 minus of 2n plus 7 divided by 2n plus 7 into 2n plus 5. On simplification, 2n and minus 2n gets cancelled. 5 minus 7 is minus 2. So we get minus 2 divided by 2n plus 7 into 2n plus 5. This is less than 0. So we have proved that an plus 1 minus an is less than 0 for all n belongs to natural number, or an plus 1 is less than an, which is nothing but our sequence is monotonically decreasing. Since it is monotonically decreasing, the sequence an is monotonic. These are the references which I have used. Thank you, my dear students.